Okay, inertia means it is the inherent property of the object by virtue of which it is unable to change its state of rest or the state of uniform motion unless it is acted upon by an external force. So any object it is at rest means it wants to be continue in the state of rest only. If any object is uniformly moving, then it wants to be in that state only unless it is acted upon by an external force. If the body is at rest, then it has to move, then the external force has to apply. Okay, and the body which is moving uniformly, if we want to stop that body, then we need to apply the external force. Or if we want to accelerate that uniform motion of a body, then again we need to apply the external force. Okay, without application of the external force, we cannot change the state of the body. If the body is in rest, then it will be continuous in that state of rest only. If the body is moving uniformly, it will be continuous in the state of uniform motion only. Okay, unless it is acted upon by an external force. That inherent property of the object is called as inertia. Is it clear? Okay. It is inherent property of the body by virtue of which it remains in the state of rest or in the state of uniform motion unless it is acted upon by an external force. Is it clear? Okay. Then we have the types of inertia. We are having 3 types of inertias. Okay. So types of inertia. We are having 3 types of inertia. The first one, inertia of rest. Okay, and second one, inertia of motion, and the third one, inertia of direction. So, what do you mean by the inertia of rest? So first I'll give an example. Afterwards, we'll see the statement of inertia of rest. So, let us consider a book which is on the table at rest. We have a book on table which is at rest. When it will move? When an external agency applies a force on it, then only it will move. Unless the external force, it won't move. Right? This is the one example. Next, I'll consider second example, that is a vehicle and the passenger, or bus and passenger. Let me consider a passenger who is sitting inside the bus which is at rest. So whenever the bus is at rest, the passenger who is sitting inside the bus is also at rest. But when the bus suddenly starts motion, what happens? The lower part of the passenger which is in contact with the bus will start motion along with the bus, but the upper portion of the passenger which is not in contact with the bus directly will wants to be in the state of rest only, because earlier it will be in the rest. Okay, when bus suddenly starts, the lower portion of the passenger, it is in contact with the bus, also starts motion along with the bus, but the upper portion wants to be in its earlier state only, that is rest only. That is by virtue of inertia. By virtue of inertia. So what happens? The upper portion will fall back. Upper portion will fall back. It is because of inertia. Right? So here I have explained the two examples. So those are the examples for inertia of rest. Now we will go for the statement of inertia of rest. Inertia of rest, it is the inherent property of the body by virtue of which the body remains at rest until it is acted upon by a force. Okay, a body, so because of its inherent property, we can call that property as the inertia of rest. Because of that property, the body wants to be in the rest unless it is acted upon by an external force. Right? This is the statement of inertia of rest. Next, we go for the inertia of motion. So now, I'll first give an example for inertia of motion, and then we go for the statement. So what do you mean by or what is the example for inertia of motion? Just to consider a passenger who is sitting inside the moving bus. The passenger is sitting inside the moving bus. Bus is moving in a forward direction and a passenger is sitting inside the bus. Now suddenly the driver applies the brake. The bus comes to rest. Okay. Now we'll come to the passenger. The lower part of the passenger which is in contact with the bus comes to the rest, but the upper portion which is not in contact with the bus directly will wants to be in its earlier state, that is in the state of motion in the forward direction. So that's why the passenger will falls in the forward direction, falls forward. That is because of the inertia of motion. Is it clear? So now then, inertia of motion means it is the inherent property of the body by virtue of which the body wants to be in a uniform motion. The body wants to be in a motion unless it is acted upon by an external force. Is it clear? Okay. Next, we have the inertia of direction. So here I consider an example. You just imagine you have seated in a car which is moving in a curved path. When the car is moving in a curved path, when the car turns to the left direction, then the lower part of the passenger, it is in contact with the car, will move left, but the upper part will be thrown right side direction, because the upper portion wants to be in its earlier direction only. Earlier direction is this one, but now the suddenly car has been turned to left. So the upper portion which is not in the contact of car directly, it wants to be in the earlier direction only. So that's why the body upper portion is thrown to the right side direction if the car turns to the left direction. Is it clear? So is there an example for inertia of direction? Then we move for the statement of inertia of direction. It is also an inherent property of the object by virtue of which the body unable to change its direction until it is acted upon by an external force. Am I clear? Right? So it is inertia of direction is the inherent property of the object by virtue of which the body unable to change its direction unless it is acted upon by an external force. Okay. Next, so in nature, there is always an opposing force for the moving body. Means there will be an opposing force for the motion of a body. Okay. If the body is moving on a solid surface, then the opposition or the opposing force of for the motion of body is called as frictional force, or we can call it as friction. Right? Whenever the body is moving on a solid surface, then there will be a force which opposes the motion of a body, and that force is called as a friction or a frictional force. But whenever the body is moving in a liquid, or we can consider fluids. Fluids means gases and liquids, both. Gases and liquids both will come under fluids. Okay. Whenever the body is moving in a fluid, there is also it's going to face opposing force for its motion, and that is called as viscous drag. Viscous drag. Okay. So when the body is moving on a solid, it will face an opposing force for its motion, and that is called as friction. And whenever the object or a body is moving in a fluid, it will face an opposing force for its motion, and that is called as viscous drag. Why I am saying about this friction and viscous drag? Because if the body wants to move, then external force is required, that we have studied earlier only, right? Why that external force is needed? The external force is needed to overcome the frictional force. Here, if any body wants to move, then the external force is required in order to overcome the frictional force, right? If the frictional force is equal to the external force, then so here the magnitude of external force and the frictional force are same, equal. Then what happens? The external force direction and the frictional force direction are opposite. Okay, the external force wants to move the body, and frictional force wants to stop the moving body. So both have the opposite direction, but the magnitude is same. Then what happens? So net force acting on the body will become zero. Then the body will comes to rest. Is it clear? Okay. So next comes Aristotle fallacy. Aristotle fallacy. So Aristotle fallacy. What it says? So here, to keep a body in continuous motion, Aristotle says that to keep a body in a continuous motion, a continuous external force is required. Okay, according to Aristotle fallacy, to keep a body in continuous motion, a continuous external force is required. Okay, so next comes Newton's first law of motion. Newton's first law of motion, and also it can be called as law of inertia. Newton's first law of motion, or it can be also called as law of inertia. Law of inertia. So what it states, again inertia only. So Newton's first law of motion states that a body which is in rest or which is in a uniform motion along a straight line, which tries to be in that state only until it is acted upon by an external force. If any body is at rest, it will continue in the state of rest only. If anybody is in uniform motion along a straight line, then it wants to be in that state only, unless it is acted upon by an external force. Okay. For example, you can take any example of inertias. You can take the example of book which is on the table. The book which is kept on the table is at rest. When it is acted upon by an external force, then it starts motion. It is also example for Newton's first law of motion. Or else you just consider a passenger who is sitting inside a moving bus. When suddenly a driver of the bus applies the brake, the bus comes to rest, but the lower part of the passenger which is in contact with the bus directly experiences that force and it comes to rest, but the upper portion of the passenger, it is not in contact with the bus directly, so it wants to continue in the state of motion only, right? So the passenger may falls forth. So this is an example for Newton's first law of motion. Okay. So in the next class, we will see about the remaining laws of motion. Okay. Thank you.